Hi, everybody. Good afternoon. Welcome to the introduction to AWS IoT session. I'm going to see it in a second. I hope so. My name is Boaz Ziniman. I'm a technical evangelist from Tel Aviv, from Israel. And today we're going to talk about AWS IoT and talk a bit about the IoT world in general. And we're going to start with a short introduction about IoT. What's IoT in general? Why is it so popular? Why so many companies are investing a lot of time and effort in IoT? We're going to talk about the challenges running IoT applications, and especially running IoT applications at scale. Then we're going to dive into AWS IoT solution and end up with some, I hope, cool demos and actually build something and give you some homework to build after the session so you can follow up the steps that I did here in some of my demos. So let's start. So I want to start with talking about IoT and Internet of Things and why there is so much interest. So there are several reasons for that, and I want to talk about some of them. So first of all, IoT allows you to build products that gets better with time. So let's take, for example, Sonos. Are you familiar with Sonos? So Sonos basically is a smart speaker you can place anywhere in your home. And you can place multiple speakers, and you can stream music into those speakers. You can decide to stream the same feed into all your speakers. You can have a different songs playing in your kitchen, another one playing in your living room, and basically play with this setup anywhere you want. And Sonos is a connected product, and it keeps getting updates over time. And when they launched in 2006, they supported only 2 streaming services, and that's quite limited. Today, they're supporting much more than 60, and this is because of the fact that these speakers are constantly connected and getting those updates from the main system. And if we take the same example of Sonos, the data we get out of those things, those smart devices, like this info, for example, describing the sources of streaming in different locations around the world, allows us to build better products and understand the market trends and predict where we should go. And it's not only general trends and market trends. We have very specific data on specific users. And this is something that allows us to build much better products that are tailored to our customers and provide them a much better service. I think one of the biggest changes with IoT is that it allows us to create new markets and basically build new offerings that were not possible before. I'm taking the example of Philips Health Suite, basically combining medical records, information about patients with some sensors and devices around his house, on him. It can be proximity or humidity or lights or anything else, and creates a new offering that connects everything together and allows the system to send notifications to people, get information from external sources, and so on and so forth. And British Gas are doing something with the Hive system, basically controlling your gas system remotely and getting information about issues that might happen with the system ahead of time, sending you a technician. So basically an offering that is very hard to provide without those things, without those connected devices. But when you're looking at the system at all, creating an IoT offering, there is a lot of effort that is required to build something like that, and especially build something like that at scale. And I want to talk about some of the challenges. So first challenge is supporting multiple protocols. When you have multiple devices, and the market is basically supporting a lot of different protocols, MQTT is one of the standards, but there are others, you need to provide a system that can support all of them, some of them, but more than one. The other thing is scalability. It's very easy to build a system for 1, 10, maybe even 100 devices, but what about millions? And the example I used before with Philips is actually connecting millions of devices into AWS IoT. And this is something that is very hard to achieve unless you're investing a lot in infrastructure. The other thing is security, and I'm going to talk about it in a separate slide, but there are new challenges with security. It's not only to make sure that you're connecting to a website that says that it's your bank and you trust this website with SSL certificates. You need to make sure that the device that connects to the IoT is actually allowed to be connected and allowed to send these messages and get this information. So there is another challenge. And of course, there is the challenge of legacy and integrating with cloud and mobile applications. If it's legacy applications already inside your organization or outside at your users, or new features you would like to provide, and how do you connect all those parts? How do you connect this physical device, you have zero control on it, with some application you provide to your customers? And last but not least, there are so many languages, so many SDKs, so many ways to write code to those devices. Some of them like really low level, some of them legacy code, and you need to be able to support them and provide a service that can basically bring those devices to the market very, very easily. So we've been thinking how to make it simple, and especially how to make it simple for developers. How do you take this smart toaster you're just developing and making sure that it connects securely to the cloud? Or how to guys in the garage working on a new startup, building a system that can scale to millions of devices, and they're doing it without spending all the VC funds on buying hardware and creating this infrastructure, and using it actually to build better, more scalable products. And for that, we introduced AWS IoT. And with AWS IoT, we build a system that is basically based on our own experience and the experience of our customers doing IoT on top of AWS before we introduced AWS IoT. And this is a fully managed IoT solution for connected devices. And we basically support the full life cycle of IoT. And I'm going to go into details for most of these parts. But the top level is, first of all, make sure that your devices can connect to the cloud and can connect securely. And this is something very, very important. The other thing is taking care of all the communication, the messages that you're getting out of your device and what to do with them. And this is a very important thing. We're going to talk about it a bit more. And the last thing, the connectivity. How do you connect your smart devices to existing applications, to other services on AWS, in other places? Something very important that needs to be taken care of, and we're going to see how we're doing it. What you get is a managed service that provides you everything you need to run your IoT solution. It's a fully managed service, so there is no installation required. We're taking care of everything for you. It will automatically scale according to the load you need. You can do small POCs with several devices. You can go out and start distributing hundreds, thousands, tens of thousands, whatever number you can think about. There is no provisioning that needs to be done. You don't need to say, this is an environment that needs to support X amount of people, X amount of devices. We'll do the provisioning for you. And it's fully redundant across availability zones and pay-as-you-go model as most of the AWS services. So basically, the more you use the system, you pay more. I'm going to talk about payment in a second. And basically, we're covering all angles. We're providing you a message broker, a rule engine, shadow, and registry. And the cost of it is $5 per million messages going in or out of the system. There are some changes in pricing depending on regions. Once again, I'm going to talk about it in more details in a few minutes. So let's talk about the different components and what each one of them does for you. So first of all, the message broker. Your devices are constantly sending messages into the system. And we provide you the infrastructure to support this communication. It can be handled in several different protocols. Obviously, MQTT, very, very important. But we support HTTPS and WebSockets. Actually, the demos I'm going to do here later, some of them are based on WebSockets. It's machine-friendly because of the protocols we support. So take into account that devices living out there, usually powered by batteries, usually has issues with connectivity, low bandwidth, stuff like that. MQTT is great for that. Power consumption, bandwidth is very, very low. And it's very important when you have a device out there that you can't reach and exchange batteries on a daily basis to take things like that into account. The connections, you can basically open a connection and pull and push constantly between the system and the device, basically have an open connection end-to-end. It's bidirectional, so you can write into the system. So there are devices that are writing, and there are devices that can read from the system. Basically, it's done with topics. You subscribe to a topic. You can write to this topic, and you can read from this topic, do whatever you want. And we support many different languages with SDKs that we provide out of the system, including mobile phones, Arduino, some development languages, the most popular ones. So anybody can choose the SDK to integrate within his system. And we make it very, very easy for you to start coding with your IoT devices and send data into AWS. The second thing is security. And security is super important. And security is really, really hard to fix when you're starting with something that is unsecured. So take security into account from the beginning. Think about what do you need inside your system in terms of security. And we provide you all the tools you need to make your IoT offering fully secured end-to-end. So first of all, we provide you the certificates, and we make sure that you can do a mutual authentication, meaning that if this clicker, let's say it's an IoT device, when it connects to AWS IoT, it has to send a certificate identifying itself, and then there should be some kind of a check that this device can send information to this queue or read from another queue, and so on and so forth. So mutual authentication is very, very important. You can manage your certificates by yourself. You can use our tools to manage them. So you have full control regarding the certificates you're implementing into your solution. And in terms of policies and access control, so there are two parts for it. First of all, the devices themselves and what they can do. So you can define what the device can do and which queues it can write to. And of course, there is the part of the administrators of the system who can access the backend of your IoT infrastructure, the backend that is running on top of AWS, and do changes, add devices, remove devices. So this is something that you can define very, very granularly using IAM policies and IAM roles. And basically, like every other AWS service, you can implement those policies on AWS IoT, same as everything else. So that's the part of security. The next part, and I think this is super important as well, is the rule engine. So IoT devices has tendency to create a lot of data. And it's very challenging to understand which data is important and which not. And for that, we first of all provide you a very simple SQL-like syntax to create rules. And it's working like any SQL you probably saw before. Select data from a specific topic with some filters. We'll take the stream of data coming from your IoT devices, and we'll narrow it down based on your query. Why is it so important? I'm going to give you an example. So BMW has a project called the Connected Car Project. It's basically tons of servers on top of BMW cars sending data into AWS IoT. And it's a lot of data. And it can be nice to have data regarding your speed and fuel consumption and even which music you're listening to. But this is something nice to have. You're going to have a nice dashboard, a nice graph at the end of your ride. It may even arrive automatically to your phone or to the dashboard of the car, showing you some statistics about your last ride. That's a nice to have. But if you're driving on ice and the sensors can actually feel that there is an issue here and there is a dangerous conditions you're riding at, what I would like the system to do is to take this information and based on a specific rule, send a message to all drivers around me that this specific road has a very dangerous conditions. And this is something you can achieve with using rules. So there will be a rule for the general data, throwing it into a database. From the other end, you're going to have a rule that in cases of emergency, it will going to push an SMS to the end user or to the other users using this system. And this is something you can achieve with rules and with other AWS services around it. So this is the idea of a rule engine. And in addition for defining the basic queries, you can do some manipulations on the data. You can enrich the data with some information coming from functions and math libraries, like, for example, add a random number or add a timestamp or something like that to your output stream. And you can combine it with information sitting on other AWS services like DynamoDB, Elasticsearch, and make it smarter. And eventually, you can route this information to multiple AWS services. So in one case, you want to take this information and send it into a database. In another scenario, you want to run a Lambda function or stream it with Kinesis to somewhere else. So basically, you can do a lot of manipulation on this stream of data after you passed it through the different rules. The next feature is the IoT Shadow. And the IoT Shadow is basically a representation of your device in the cloud. And you can store those representations back in time for up to 1 year. And you can access it from different sources, like, for example, from your applications. And instead of going on all these bullets, let's have an example. So let's say I have a smart lamp at my home. And this lamp right now is turned off. And on the other end, I have an application that controls this lamp. So what actually happens with shadows is that this lamp will provide the current state, and this state will be written into a persistent storage on AWS IoT. And right now, the storage says that the lamp is off. And I can actually query the status of this specific lamp coming from my application. So the application will ask for the current status. It will get the status from AWS IoT. It will show physically on the application if it's on or off. And then I can change the status. But I'm not actually changing the status. I'm sending a request to change the status. The request will go to AWS IoT. From there, it will go to the device itself. The device will change the status, send it back saying that it was published. It will be stored again. And only then the application will be updated with the current shadow. So basically, you have here a cycle that you can go on and do changes to remote devices to your things. So let's do a short demo, playing a bit with shadows. So please take out your mobile phones. You have a QR code here that you can scan. If you don't have a QR code scanner, there is a URL at the top. Just make sure you're using the right case, because Bitly is case sensitive. I'll give you a few seconds to get. You can do it with mobile phones. You can do it with your laptops, iPads, whatever. Ready? You have a light bulb? OK. So are we flicking a bit? OK, so basically you see this thing. But there is a slight difference between what you see and what I have on my screen. So I'm controlling your light bulb. So basically, this is the application that controls the light bulb in your home. So right now, I can go and turn it on. Worked? I can't see your phone. Come on, show it to me. Thank you. And I can basically keep playing with it and now go to 50% brightness and do it and turn it off completely and turn it on again. Basically do whatever I want, and I'm controlling all your devices from a single application on my laptop. So let me show you what's going on here. Okay. So basically, you were all connected to AWS IoT. All your phones got a very basic web page that behind the scenes with WebSockets was connecting to AWS IoT and reading the shadow of my device. I was the device, okay? And my application is basically changing the device shadow. And each time I'm changing the device shadow, your application is reading it and changing your light bulb according to what I was sending. So this is just a very simple example how to use device shadow. And here we were, I think, maybe 100 people. I hope people on Twitch was joining this demo as well. So maybe a few hundreds of people in this demo, but no infrastructure. I didn't make any special preparations. And I did this demo for 500 people, and it worked exactly the same. So scaling, provisioning, everything was taken care of by AWS IoT. We're going to do another one, much nicer in a few minutes. The last feature I want to talk about is AWS IoT Registry. Basically, this is the place where you're managing your things. You can store the information about the things that are part of this deployment inside the registry. It's mainly used to store metadata regarding your devices, things like serial number and firmware version and maybe the name of the person that's holding this device, so on and so forth. Just a registry to make sure you have the information in one place. And I said before I'm going to talk about pricing, so let's talk a bit about pricing. Obviously, a pay-as-you-go model, no minimum. You can use it as much as you want. $5 per million messages in or out of the system, except for Korea and Australia, which is 6, and Tokyo and Singapore, which is 8. So if you're running in these regions, please take it into account. You have a free tier that you can start using today, 250,000 messages per month for the first 12 months as part of the AWS free tier, the regular free tier you're getting with every new account. And if you're planning to do a large deployment, we have enterprise pricing. So please talk to your account manager regarding your needs and your deployment. So this is regarding pricing. So basically, I covered everything that is included in AWS IoT. And before going and building something, I want to do another demo. So your phone are still out? We were waiting for this, right? So another QR code, another URL. People on Twitch are more than welcome to join the demo as well. I need as many people as possible on this one. I really want to stress the system as much as I can. So I'll give you 10 more seconds, and then we're going to switch to the demo. So you're supposed to see something like that. 9 colored cubes on your mobile devices. Ready? OK. Not this one, this one. It's already clicking. OK, never mind, that's OK. So basically what we're going to do is there are 2 parts for this demo. And the first part, we are going to choose your favorite color. So I'm going to give you 10 seconds to choose your favorite color. Please click on the color that is your favorite color. I'm sorry if your favorite color is not in this box, but choose something similar. And in 5, 4, 3, 2, 1, the winner is green. Congratulations, green. Who chose green? Well done. OK, so this is one part. As you can see, basically, you have all your clicks in this rotating cube, which is pretty cool, but it's just cool. It doesn't do anything. And you have the colors here, winning color, votes per second. There is a nice graph. I hope you can see it. It's a bit dark that shows the load on the system. Now I want to do something else. I want to do another game. And in this game, I want to stress out the system. And I want to stress it out by letting you press as many times as possible for 20 seconds on any color you want. We are not going to announce another favorite color. It's green. Done. But I want to stress out the system. And you have about 20 seconds now. Press as many times as you want and watch those numbers. Watch those numbers. Let's see the jump. We're already at 100-something requests per second, votes per second. And it actually depends on the number of people. We're soon going to have the cube full. Come on, you're too slow. OK, I'll give you another 5 seconds, and I'm going to announce the winner. By the way, the winner is the person that clicked the most times on the application. And it's 5, 4, 3, 2, 1. Somebody got the message? Nobody got the message? Maybe on Twitch? Try again. We have a winner. So here's the winner. He's the guy that pressed the most times on the colors. There is a prize. Come to me after the session. But congratulations. And that shows you how fast we can scale something like that. You can keep pressing, but I'm going to switch back to the slides just to show you what we were doing here. So this is slightly different than the previous one. Thanks for the comments on Twitch. So this is slightly different one. Once again, I'm using here a serverless architecture to make sure there are no servers here. I'm not using servers at all. I'm putting my static web pages on S3 bucket. I can use CloudFront. I skipped it this time because we are in a single location. There is not a lot of value for that. So just serving the page from S3 bucket. You're writing your votes to AWS IoT, but it's not just writing your votes. It's your votes and a token coming from Amazon Cognito. Amazon Cognito is a service to manage users. And each one of you basically got a unique identifier the first time you got into the application. And I'm sending this unique identifier together with your vote. This is how I know you're the winner and you're the one that clicked the most time. Everything goes into my browser, into the control application. And all the calculation, all the presentation is happening there. In theory, I could put a database here and log your votes into a database. But for the purpose of this demo, that works perfectly. I'm doing it all client-side, all in JavaScript, and it works pretty good. As I said, I did this demo for 500 people. It was still working with much higher loads. So, but you can obviously extend it and do some other things. Add databases, add more sophisticated stuff. But this is one way to do it. So those are the two demos that I was doing all by myself. The next one, I'm going to give you some homework. And I'm going to send you out of this session with a very clear target to create your first IoT application. So let's build. And what I want to build is something like that. Basically, I'm building here a very simple system for Airbnb hosters that put an IoT button. Where's my IoT button? I lost my button. I'll find it in a second. It's in my pocket. So basically, an IoT button. This is an IoT button. I'm going to explain about it in a second. This IoT button will be used as a check-in and check-out button for an IoT, for an Airbnb apartment. And the idea of the IoT button is to provide developers with a very, very simple tool to play with, to understand AWS IoT better. So the idea of this thing is that it's very easy to connect it to AWS IoT with the security credentials and Wi-Fi and everything else it needs to be connected. And I'm going to show you the process in a second. I have a short video that I recorded on my phone how to do it. You basically define it with your mobile phone. And then click on the AWS IoT button. We'll send an MQTT message into AWS IoT with some rules that I already defined. I'm going to run an AWS Lambda function. AWS Lambda is our serverless functions that basically we take care of all the infrastructure. You're providing us only the code. And it's a very, very simple code. I'm going to show it to you later. I'm not a big Python developer, so it's pretty ugly. But still, it works. And the result of this function will be two. One, I'm going to write down into a DynamoDB database that somebody did an action with this button. The other thing, I'm going to send an SMS. And I'm on roaming, so I'm not getting those SMSs fast enough. But let's hope it's going to work right now. That provides this information for the owner of the apartment that somebody just checked in. And from the other end, there is a management application that is hosted on S3 with a static website. And this time I'm using CloudFront basically to distribute this around the world that will call another Lambda function with API gateway that will read the information from the database and display the status of my apartment in real time on a screen. So the first thing I want to talk about is how to set up this thing. So when you're getting an IoT button, the process of setting it up is basically downloading an application that manages IoT buttons to your mobile phone and just following very, very simple steps. I have a very short video here that basically describes it. So this is the home page of the application. You're supposed to check to select your region at the bottom. And then basically it starts with setting up the device itself. There is a QR code on the back of the device. I just need to scan it. As soon as I scan it, all the information about the button is already in the application. I'm registering it with AWS IoT, getting all the credentials, keys, everything I need through the application, connecting it to Wi-Fi, first by making this an access point, connecting to the device, setting up the Wi-Fi network that it finds on my local one, providing the credentials, obviously. And after this step, it's basically fully configured and can be used and send information to AWS IoT. You're done. Now, there is the other side of what it should do. The last step is basically defining, come on, thank you. The last step is basically defining the action. What will happen when I'm doing an action on this one? You can choose from available functions, like send SMS, send an email, or you can choose from your own functions. I'm using IoT dev log click for this specific example. And this is what it's going to do. And this is the Lambda function. And you're basically done. This is working. One last thing I need to tell you about this thing. It has 3 modes of click: single click, a double click, and a long click. The long click is a bit tricky because a long click of more than 6 seconds activates the access point here. So it has to be less than 6 seconds. But anything around 2-3 seconds should be OK for a long click. And you can actually create different actions based on the type of click you did with this one. So let's see how it works. So this is my front-end page. Hopefully, all the network components here are connected and everything is working. And what I'm doing now, I'm doing a single click. When it sends, it's actually going to be green. Is it green? Come on, connect. Yeah. So it's green. It actually sent something. I did a single click. This is a check-in. And after a few seconds, and I don't remember the interval of the pooling here, my web page will change into check-in mode with the current timestamp of my check-in. And when I'm done and leaving the apartment, I'm doing a double click. It will send a different type of string into the system, and I'm checked out. And then there is the cleaning company coming in, cleaning everything together. And when they're leaving and everything is ready, they're doing a long click. And the status should be changed into, come on. Come on. Ah, I did a short click. This is one of the problems. Like the single click and the long click sometimes confuse you. I'll try to do it again last time. Hopefully this is long enough. OK, so it works. So those are the 3 different modes that you can actually work with. What do we have here behind the scenes? So this is AWS IoT. This is the console. I have several devices here from all kinds of demos I'm doing, but the one we're talking about is the IoT buttons. The IoT button with the ID that I have on the back, same one you're getting from the QR code. This is part of the registry. So this is where I'm storing the information about my devices. And I can go into the device and get the information about it. The endpoint, it's Shadow, but I'm not using Shadow, so it's not really relevant. The other thing, I have my rules. And once again, the rules are per device. And for the IoT button, I have a rule that says that each time I'm getting any message into IoT button, and this is the name of the topic, invocate a Lambda function, the one that I showed you during my setup, IoT demo dev log click. By the way, if you're taking the name of this topic, you have a very cool interface that's called test that you can subscribe to a topic and see those clicks in real time. So I'm now subscribed to the topic of this button. I'm doing a single click. And you're going to see the message coming in. It's sending you the serial number of the device, the battery voltage, and the click type. So I can do a double click. You see the double, and I can do, hopefully, the long one. Now I'm going to say something else. And I got the long one, and you basically can debug your devices with this test interface. Obviously, this is pretty simple, very simple communication, but there are some devices sending you tons of data, sensors of temperature, humidity, movement, stuff like that can send you very large chunks of information. And you can see it in real time in this console by just subscribing to a specific topic. You have a dashboard that shows all the connections, how much traffic basically is going on to the system, and what am I doing it. And the last thing I'm going to show you is the backend. So as I told you, there is a Lambda function that basically takes the information and just store it into a DynamoDB database. So this is the function, pretty straightforward. I'm getting the information from the event, parsing it a bit so it looks nicer, save it into a database, doing some time zone manipulation so I can actually get a time in the local time zone. I can change it inside my code. I can do a variable and do it somewhere else. At the end, I'm sending a message. I'm still not getting SMSs. I have no idea why. But if this is the only problem with my demo, I'm fine with that. OK? So what we actually build here. So the first part is the part that is taking care of the communication from the IoT button into AWS IoT, invocating a Lambda function, and then out of the Lambda function, basically writing into a database and sending an SMS. And the second part is basically serving a web page that people can go and check the current status of your Airbnb apartment and see in real time what's the status of the users inside this apartment. If you want to do exactly the same thing, there is a blog post on AWS, Amazon.com. I created here a bit.ly link, one-click IoT. It basically does exactly the same thing, more or less, with some extensions, even connecting it to IFTTT app, so you can do all kinds of things. You can extend it to turn on the lights when somebody checked in and turn off the lights when somebody checked out, and play with it and do exactly the same thing that I did here, more or less. I tried to do it a bit simpler so it will be more dimmable, but you have all the step-by-step inside this blog post with all the explanation exactly how to do it. So what should be your next steps? First of all, play with it. Go to the console of AWS IoT, play with it. It's super simple. Adding a device, defining it, creating the rules. If you ever wrote an SQL statement in any SQL language, it will be as easy as that, including the more advanced features of functions and adding content outside of the messages. The other thing, we have a lot of content on aws.com/IoT platform, both for general content and for people who want to get started, including full information about the SDKs and what you can do with your specific environment. Get an AWS IoT button. So if you have an AWS IoT, if you don't have an AWS IoT button, get one. This is the easiest way to start with AWS IoT. Obviously, you can play with many more things. I know Danilo is doing a demo with Raspberry Pi in his next session, and it's super easy to do it on Raspberry Pi. The process of connecting it, it's a bit longer, and you need to go into AWS IoT and download the certificates and put them on your Pi with the IoT button, and everything is happening behind the scenes for you, and it's super, super easy. But it's not that difficult to do it on other devices as well. The JavaScript SDK is very, very popular, and a lot of people are using it to integrate into their web pages and mobile apps. So this is another way to find ways to work with AWS IoT. Any questions? Any questions? Yeah.
The timestamps you're getting there, where do they apply? Are they when you press the button or when it arrives? Do you get any intermediate timestamps?
So I just repeated for Twitch. So the timestamps in my demo app, where are they coming from? Is it when I click the button or I have something in the middle? I don't remember exactly how I'm doing that. I think I'm injecting it during the rule as part of the query I'm doing, just adding timestamp to it. Not sure. Maybe I'm doing it in the rule. Maybe I'm doing it in the Lambda. I don't remember. But you can do it in both ways.
It's kind of a later question. If you're using MQTT, how do you handle messages that don't get through? Because MQTT is very good guaranteed delivery.
So if you're using MQTT, how do you handle messages that don't get through? So there are several ways for quality of service for MQTT. And you can actually define them for your different topics. You can define deliver at least once or only once. So there are some things you can do with it. You need to have a backend as well that can handle malfunctions and connectivity issues and stuff like that. And actually, it's pretty popular for IoT devices to be disconnected. And this is something we're not really covering here. I know if Danilo is talking. Danilo, you're talking about Greengrass, right? So next session, Danilo is going to talk about Greengrass and what are you doing on the edge. And this is something that extends the basic of IoT into edge devices and allow you to do things that are more complicated and has to be like a transactional operations and stuff like that. But we've been covering the basics. I'm going to stay on this level. Yeah?
Is there a way to figure out if the device is online?
Is there a way what?
To figure out if your button's online.
If my button is there a way to figure, if this one is online?
Yeah, is it there?
Not that I know of. No, it sends information, it's not registered. But if you have a device that reads information, I assume you can constantly send the ping or something like that. But this one, no. More questions? Anything on Twitch? So let me just have a look. OK, so there's a question on Twitch. Where does Cognito come in here in the color demo? So basically, Cognito, in this case, is identifying the users. I think I said it during the demo. I need to know not only the voting, but who's doing the vote for the second game with the winner. So with every vote, I'm getting a token from Cognito that basically sent together with the click itself. This is the part of the integration. What?
So a user on Twitch asks, is the source code the color demo available?
So yeah, so the link I gave here, just repeat the question, is the source code for, sorry, the color demo source code is not available. Actually, I'm gonna add to the slide another resource of some public IoT demos that we have on GitHub. Some of them are very similar to the color code. The source code for this one is available. You can basically download the Lambda function as part of the instructions in this blog post. And I'm going to add to the resources of the slide that we're going to send later the link for the public IoT demos we have on GitHub. Any more questions? Thank you very much.